everybody, and welcome to Between Two Servers. This is the show where we talk about multiplayer game development and netcode. With me today, I have Iggy King. Welcome to the show, Iggy.
Yeah, thanks, Glenn. Great to be here.
So Iggy has a super long career, a lot of work on sports games and RTS games, experience at Central Tech Team at EA, worked a bunch on FIFA, and now Blackbird Interactive working on RTS games. So there's a lot for us to talk about today. Why don't we talk about how you first got into games?
Yeah, sure. I guess it first started in the 80s. I got a Commodore 64 when I was in grade 11. Prior to that, I'd been reading books, and Dad got me this set of books because there was no internet then. So, you read books. That's how you found stuff out. There was a Tic Tac game that couldn't be beaten in 10 lines of BASIC, and I thought that was amazing. So I started writing my own games.
I wrote that too in BASIC, but I was like 10 years after you.
Right.
So
I wrote Unbeatable Tic-Tac-Toe, but I did it like the way I play tic-tac-toe. So it was like pages and pages of code.
Yeah. So you actually did the whole decision tree from everything and you coded it out?
I probably special cased it all. It's like, okay, if this happens, then
that is exactly what I did too. I literally did the whole decision tree from every starting point and coded it with like if else's and boom. Yeah. Amazing.
I made a few other games. I did like a Space Invaders ripoff and a driving game, and started getting into assembly programming on the Commodore 64 and using sprites, and built my own sprite editor. So I was doing like tool development in grade 12, I guess it was at that point. And
so we're talking like 80s now? Yeah,
this was like 84, 85.
Cool.
And then, that fired me up about computer science. So I went and studied that at university. Went on and did a master's degree. That's what brought me out to the West Coast. And from there, my first job out of school was doing embedded DSP development at a local hardware company that had a small software division.
Very, very cool. So from that, you got into EA on the Central Tools group, working on some really old school consoles. Tell me about those.
Yeah, so that was 1995. I saw an ad in the Vancouver Sun for a tools programmer at Electronic Arts, and I was like, oh yeah, I remember seeing ads for them in magazines, but back in the day. So kind of on a lark, I sent in my resume and got an interview and got a job offer, and I was like, oh, okay, I guess we're doing this. Let's do it.
That's rad.
Yeah,
that's so cool.
Super fun. And the Central Tech team, they had a library of low level like file IO, sprite rendering, math library, stuff like that needed to be ported onto each new platform as it came along. So they put me, I think the very first thing I worked on was getting those libraries up and running on the Sega Saturn. Then I moved on to they had a custom video codec they built that EA patented, and I did the implementation for the 3DO, which was kind of fun because the video player was based on 8-bit paletted videos, but the 3DO, I don't know if anyone remembers, had a really weird coded 8 color system where you got, I think it was eight shades each of 32 colors. So
so it's almost palette. It's
like a palette.
Paletted,
you don't get arbitrary choices. Yeah.
So was it? So it really was was it 8 gradations for how many? 32.
32. Yeah.
So it was 8-bit, but you didn't really have.
But it also meant that when I was, the stream had been encoded on a PC with no notion. Yeah. It was just reducing to 256 colors. And when I matched those onto the best fit of this gradated palette, it looked kind of terrible. Yeah. So what I ended up doing instead was doing just software paletting to a 16-bit output. And we managed to get that working. So
this is sort of like to sort of set the scene, this is back in the era of debabilizer and not everybody having 32-bit color, and before 3D
before 3D effects, before Power VR, none of the consoles were doing 3D yet.
It was sprites and it was paletted color, and the challenge was getting authored 2D content into a limited color range, and there were tools that were optimizing and dithering and so on. And for video, you had to do a similar thing on the 3DO. That's crazy. So Saturn and 3DO didn't go very far, but it must have been quite interesting to work with them back in the
I hope
day.
It wasn't my fault, but I remember on the Saturn,
you killed them, Iggy.
Yeah, I don't know. Our studio, EA Burnaby, did a whole lot of sports games. So it was all about, FIFA soccer, baseball game, basketball. And so the Central Tech team worked a lot on the sports titles. I did also get a credit on Warcraft 2 for the Sega Saturn. That was fun. I was like the EA liaison with the third-party developer.
So
okay. It's neat to see that game coming together. And years later realized just how big Warcraft had been back in the day. I didn't really know what I'd been part of at the time, but
that's amazing.
Yeah.
So you were initially on the central tech group, and then you got pulled to the FIFA team.
Yeah, I got pulled into FIFA.
That.
So I was working on the Nintendo 64, and FIFA was going to be the first EA title, or at least the first for the EA Canada studio to come out on the N64. So again, I was porting the low-level libraries, but also getting into the, how the fixed function pipeline for graphics worked on the N64, and helping take advantage of that, and liaising very closely with the FIFA team, because they were kind of like the first candidate. I'd make a change to the library, and with days later they'd be using it. So I was working very closely with them.
Huge? Was it as huge back then as it is now?
It was a massive project. It was probably the biggest team at EA Canada, but nothing like the small industry it is now. I mean, you look at probably saw the news this week about the FIFA potentially changing their name because they couldn't come to a licensing agreement with the FIFA governing body, the Fédération Internationale de Football Association, or whatever it's called. I feel like FIFA should be paying EA, because I think all the name recognition of FIFA is from the video game, not from the governing body. But anyway, $1 billion for that license, and all you get is 4 letters, seems like a hefty price to pay. So I'm not surprised they're stepping away from that.
Yeah.
So yeah, back in the day, 1996 or 7, whenever this was, the FIFA team at EA was probably 80-ish people doing, building a game every year for 3 to 5 platforms, depending on the year and where we were in the console cycle.
That's insane. I mean, that's even hard today, doing it in a year. And back then, I mean, this was real hardcore low-level programming on these consoles. This was basically like, congratulations, you're writing a device driver.
Yeah, pretty much. Like you're learning the assembly language, you're learning exactly the cache architecture on this machine and how to optimize for it. You're dealing with file IO. On the N64, we didn't really have a file system, so we wrote the file system against cartridge memory instead, just to allow a bunch of other code to work more cleanly.
Yep.
And then independently, we wrote a motion playback system that would pull animations off the cartridge, but then have a little buffer of them in memory. So the one, the run cycle and the things that were happening a lot would be right there and available, and you'd only pay the cartridge hit when necessary.
Did they have like a shared code base? When I did console work, I did some work at Pandemic, and it was sort of almost like a PC based studio that also happened to do consoles. Then I got to work at Sony Santa Monica, and these were really hardcore people like you. I mean, they'd been there on PS1 and PS2, and I mean, this is real shit, right? Like, it's not a PC, right? It's an extremely low level thing and very bare bones. What I'm really curious about is, back in the day, was the N64 just radically, completely different to the Saturn, to the 3DO in terms of how you would program? Or was it that you could have a reasonably similar shared code base and kind of have drivers or stuff? Like, how did it work when you had such divergent architectures?
Yeah, that was where this low-level library I was referring to would come in. So that would give kind of a foundational layer that the game teams could then write against. And so they would try to write as much shared code as possible. In the case of FIFA, they were split up into a number of sub-teams. So there was the gameplay team, and all the gameplay was built using shared code that would just be written once. The UI team might have to do stuff that was platform specific, depending on the UI framework in use. Networking would be generally platform specific at the low levels, and then try and have a higher level abstraction that was.
And of course, no cross-play back in the late 90s.
Yeah, although ironically, I think we could have, because we were running the same simulation code, and we used fixed point math, and we just treated the players were treated as remote joysticks. So essentially, it was the same sim running everywhere, and I guess there'd be issues around like versioning and exactly which build went out on what platform. But technically, at least, it should have been possible to do crossplay, but nobody was considering that back in those days.
Very cool.
Network play was usually something you did with your friends in their house or over
like a LAN situation.
Yeah, exactly. Yeah.
So did FIFA actually start there in the LAN? Is that the origination of the FIFA multiplayer?
Yeah, I believe so. Yep. Yeah. So LAN play would have been the beginnings of it. I think we first did internet play while I was on the team, but I can't remember what year that would have been. That wasn't really my domain at that point.
Yeah.
And the way they
I
did
feel so sorry for the person who did that at that time.
Yeah, Ben Cho, it was always, he'd be, you know, anytime there was a determinism bug or anything like that, he'd be the one who had to like dig into the bottom of it, figure out what was going on, and then communicate back to the person who'd, you know, forgotten to initialize a variable or messed up the random number generator or whatever had gone wrong.
So let's talk a little bit about determinism and lockstep. So I'm just going to go out on a limb. I've never worked on a sports game. I don't know how they're networked. I'm going to assume that they're probably deterministic lockstep based on what you're saying. Were they peer-to-peer back then? Just what's the general kind of best practice that you've seen for the sports games?
Yeah, I mean the way we did it was definitely peer-to-peer lockstep. We would, again, it was just gathering remote inputs. So if I'm playing against you, to my game, you just look like a remote controller, and same thing in the other direction. We would gather up the button inputs and the you know, all the directional inputs, package them up, send them over. To be honest, like since being at Blackbird, we've followed that pattern for real-time strategy games. I didn't realize when I was working on FIFA that it's kind of an RTS game in disguise. So, you know, it was helpful when I had that realization. It was like, oh, all that stuff that Ben used to do, I should rack my brain and remember how it works and then read up on that stuff, and we can apply that here.
That's awesome.
What I'm not sure of is like we go to great lengths to try and hide network latency and make sure that, you know, we're not pausing the game, waiting for the packets to come in. So we're scheduling those packets to be consumed a couple of sim ticks later than we send them, so that those 2 ticks can be used for the network latency to happen.
So it's the classic thing, like you might locally play, like the classic RTS thing is like you click and then the local UI goes like bloop and goes like, and the guy goes and he might play like a cosmetic animation, on my way, sir, but like he's not actually going to move.
Yeah. And so he might not move for a few hundred milliseconds, which usually in an RTS is okay, because you're, you know, the feeling you have as a player is that you're telling your units what to do. You don't identify with the unit.
So in a sports game, is it the same?
In a sports game, I feel like that doesn't work quite right, because you obviously you want very responsive control to the player, and so you would want, you know, the moment I push left, I want my player to start moving left. So I honestly don't know at the time if we just got around that by the fact that you're on a LAN, so there's very little latency, and we're running the sim fast enough that the reaction time is okay. You know, I kind of want to go back in time and have former me talk to our network guys and learn more about it. But
that's really interesting. I'd hazard a guess if the gameplay simulation wasn't particularly CPU bound. And I'll guess that it probably wasn't, although on some of the consoles, maybe it was. If it wasn't particularly CPU bound, it might have been that they did an early version of what's known in the industry as GGPO, or Good Game Peace Out, which is the sort of rollback that's used with deterministic fighting games.
Because I know we were storing replays as command stream sequences, but we weren't able to scrub forward and back. So I don't think we had a robust like state per tick management system.
You're making a game every year. I would be stunned if you could even get the game out, let alone re-architect for a rollback based system.
I also know that like the gameplay team didn't generally have to worry about networking. They just consumed inputs and ran animations and things. So I feel like the networking would have been a lot more invasive.
Yeah, the lovely thing about the deterministic lockstep is that, you know, like if you're deterministic, down to a bit level, down to a checksum of the game memory state at the end of a frame, or even in partial frame points when you're binary searching to debug what went wrong, the game code, as long as it's deterministic, just networks. It's beautiful.
Yeah, just play by the rules and everything becomes pretty simple.
Yeah. Amazing. So after this, for a while, you went on to become tech director at Central Tools Group, and I think, did you spend a bit of time working with the art pipeline there? What was the Central Tech transition?
I migrated through a group called Sports Core. So we were looking at, you know, we're making all these stadium-based sports games. Why aren't we sharing more high-level stuff? And that we tried a bunch of things, some of which worked, some of which didn't. The best thing that came out of that was like a human character animation system suited to the needs of sports games with, you know, rich behavior trees and basically a lot of foundation for building gameplay, not just, you know, moving a character. So it was a lot more sophisticated than like an FPS first person controller or whatever. So that was one thing that came out of that Sports Core initiative. I then moved on looking at, we were try to centralize the content production process. So I started looking more at pipelines for art teams, ways to manage their content, ways to make sure that content for hundreds and hundreds of player likenesses, mapped into the database and was, matched the new roster updates and things like that. Looking at database technology to manage those rosters, working with.
What year was this roughly? Like 2010?
This would have been, so my last full-time year on FIFA was the FIFA 2003 iterations, which would have been done in 2002.
Yep.
So then this was 2003 through to 2010 was when I finished my time at EA. And yeah, we did a lot of time building our tools, streamlining content pipelines, making it easier for central groups to standardize on best practices and deliver into multiple game clients in an effective fashion. So it was almost not exactly production management, but kind of.
It's a very interesting area, particularly in that time frame, because that was the time frame of the transition from the PS2 and the Xbox gen to the PS3 and the Xbox One. And man, content just exploded. Like the size of content being processed, the baking, and these consoles at that point were next gen to us at that time working on them. But even though they were much more powerful than previous ones, the expectation was that the step up in production quality and assets and art was really high, and it became very difficult for at least teams that I was working with to manage that whole process and pipeline. So I can certainly understand EA's position of trying to make that simpler across multiple sports studios.
Yeah, exactly. And like the data, the content got a lot bigger. There was a lot more of it. It wasn't just put a material on a model. Now you needed like multiple layers of materials, and somebody was writing a shader, and the artists need to understand how that shader became their material. And then you're hooking up all the textures and, figuring out, in FIFA's case, what's a common texture, what's based on skin tone, what's based unique to the player, what comes from their team. Like there's a whole bunch of things that come together to assemble a character in FIFA, and similar issues on the other titles as well.
Very cool. So you since left EA and you find yourself at Blackbird Interactive now as technical director. You shipped Homeworld, Deserts of Karak, which, unlike people who like me remember the original Homeworld being a space game, it's actually a ground-based RTS. So was this the first real RTS you worked on?
Yeah, I mean, other than being remotely involved in Warcraft 2 back in the day, this was definitely my first real RTS experience.
Yeah. So what was it like, and did you get involved with the networking at this point?
Yeah, so it was a super fun project. Blackbird started in 2010. Originally, we were looking at Zynga making, bags of money on Facebook with games that we thought didn't look that good and weren't that interesting. We thought we could do way better.
Kind of feels like blockchain right now, although I don't know if blockchain ends the same way as
we'll see. And yeah, we wanted to do high quality 3D on the web, and we chose Unity because they had a Unity plugin that would do quite good graphics in a web context. In the end, Facebook gaming went away before we really figured out what the heck we were doing. And
by the time you see someone succeeding with it, it's already too late.
Yeah, I guess we should have.
I think. But
yeah. So our idea was to make a desert planet game where you're driving massive vehicles over the surface of the planet. You're interacting in a map level, dropping down into 3D on the surface of the planet. You're getting little pop-up videos with Intel moments. Our CEO, Rob Cunningham, is super excitable and persuasive and convinced me it was going to be mostly an art problem and I just needed to come and assemble a few key pieces of tech. And I'm like, oh, that sounds awesome. It's new. It's
siren
fun,
song.
It's going to be easy. But yeah, I think we sort of had, it was like
5 years later,
new tech, new game genre, new business idea, new team. Like there were so many things new that we naively assumed we could solve all the problems, and didn't quite work out that way. Anyway, we ended up getting in discussions with Gearbox, who bought the rights to the Homeworld IP. Rob Cunningham was art director on the original Homeworld titles at Relic, where he was a co-founder. And so Gearbox came to us looking for like art assets and audio that was, on tape in a cardboard box in Rob's attic and things like that. So we were doing all this forensic investigation of how to help them revive Homeworld. And then we kind of got talking about this project we were working on, which at the time was called just hardware, but it was this, desert planet, big vehicles thing that always sort of could have been in the homeworld universe if you squinted a little bit.
Yeah.
And so we decided to work with Gearbox and turn this into a prequel to the homeworld. So, the story of homeworld comes about after the planet of Karak
people
disappears in flame, and everyone's trying to get back to the homeworld.
This is something that's so important for people watching, especially at the beginning of your career. It's not always a straight line from starting working on a game to shipping it.
Yeah, for sure.
Like
we kept
this is a journey.
Yeah.
Every game made is a miracle.
It is, yeah. I mean, games are so difficult, and that's part of what makes it exciting. And you're working with such a diverse group of people. You're solving hardware problems. You're trying to squeeze out performance. You've got to make it fun, which is, it's so much different than just developing application software or working on a database or whatever.
Can I let out a secret about console development, shipping games? So, some of the older school senior, I was a senior lead on the God of War team, helping network the God of War engine. But some of these guys have been around for ages, like God of War 1, 2, 3, whatever. And they were old, salty console guys. and so one of them, I think we were coming up at the end of, I don't remember if it was God of War 3 or God of War Ascension. And the guy just, it's like, we're really, really tight. We're not sure we can make the memory. And so he just goes into his code and he goes and edits the static 1 meg that he'd reserved already.
Megabyte tucked away. He's going to give you half of it.
Yeah.
I think that happened once on FIFA too. I forget which platform.
Yeah, it's an old console trick, right? The old console guys always hold on to a little bit of memory because they know that the art or the level or something deserving, obviously, is going to need it, and you're just not going to have room. And this is going to be right before you go gold, right?
Yep.
So pretty cool. Well, so Homeworld Deserts of Karak, you shipped that.
So I mean, you were asking about the networking and that. So
tell me about it.
I didn't implement it, but I was involved in it. I was heavily involved in setting up the sort of peer-to-peer architecture and the gameplay side of how we were going to receive inputs and pass commands around and things like that. We didn't just network the inputs. We basically had user input coming in and turning into selection commands and move orders. And then
so at a sort of like
the network.
Like a command, like the post translation of input into commands was the networked primitive.
Yeah, correct.
Cool.
Yep.
Okay.
And then those primitives would get distributed over the network, queued up, and each one would have been stamped for execution at a certain sim tick. So we were running things like, I think we default to 2 ticks in the future, which actually in the end, the optimization was a big challenge, and our simulation was fairly heavy. We did a last minute optimization of dropping the tick rate from 10 hertz to 8 hertz, which seems frightfully slow, but actually worked okay for an RTS game.
So one thing that everyone needs to know is that RTS games often render at a different rate to the internal tick simulation. So
and so we're rendering at 30 to 60 frames a second, assuming we can. But then the sim has to run at a very precise rate, and every frame needs to execute because the state of each frame is dependent on the state of all the previous frames. That's where the determinism comes in.
Yeah.
So, it's essential that as each new command comes in, that command is going to get executed for all 8 players in the match or whoever's playing. It has to produce the exact bit equivalent results for every player. And so, we need to make sure that they're all executing on the same tick so that we're getting the same inputs and therefore are able to generate the same outputs.
Got it. So what happens if one of the 8 players can't send packets to all the other players for a second?
Yeah.
Not saying they're using a lag switch, but maybe they are.
Right. And so the issue there is that, you've scheduled you've generated a command packet, you've thrown it out onto the network stack. You need everyone else's to come back 2 ticks later, which is 2/8 of a second. You've got 250 milliseconds, and you're hoping that's enough time for everybody to, share their results.
So it really looks like you throw it out to everybody, and then everybody throws it back to you, and you're like, now I have everybody's commands for the time I'm about to execute.
Yeah,
and it's like a loop out and come back.
Exactly. Okay. And so where it can go wrong is if if one player takes, like you said, a second to send their results, then everyone's sitting there like, oh, I don't have your results, I can't run my tick yet.
So did you actually pause at that point?
Yeah, we would pause briefly, and what we would do is pause and wait, and then update the number of ticks in the future that we were scheduling for. So, if we initially default to 2 ticks, if we miss that deadline a couple times, we'll try 3 and see if that keeps us going. If not, we'll try 4. And so you get this trade-off where you've got.
So this is almost like a play-out delay jitter buffer for that particular player, assuming good faith.
Yeah,
it's kind of so like maybe they're a little bit early and late and their connection sucks. Let's just move them a little further into the future than normal.
Yeah. I mean, unfortunately, you're having to wait for you're delaying, you're slowing down the game for that, but you're not slowing down the frame rate. And if you've, worst case, if you were waiting, let's go extreme and say you were waiting 20 ticks for those packets, that gives you 2 seconds for all the networking, which should be plenty, even if you're networking between,
is it just that player who has the 2-second
delay?
No,
then everyone's gonna get delays. So they're gonna issue a move order. They're gonna select units. They're gonna click the map, and it's gonna take 2 seconds for the units to start moving.
Got it.
Which would be pretty bad. But if it's in the, even 200 to 600 or 700 milliseconds is not terrible for an RTS game, and presumably you're playing against someone in another continent. And you're like, yeah, okay, it's cool, it's working, whatever.
Yeah. So when we move past the internet sucking, which definitely in that time frame it did, and even today you can't really rely on timely delivery, although it's statistically probably a lot better. There's a thing called a lag switch where people just can be dicks, and I actually had to buy one surreptitiously from a great website when I was working on God of War, because we couldn't pass our submission because they were like, if one person lag switches, like the rest of the it was something like if someone lag switches, their attack was unblockable or something like that, right? And of course it all goes back to the network model that we were using, but in this case, I think I've got a solution that I can share with you. I think that StarCraft or StarCraft 2, what they did is they had an input server or a command server that would take the process commands. So instead of going out peer-to-peer and throwing back, everybody would go out to the input server, and the input server would be able to arbitrate. Well, this guy's too late. Your commands are toast, my friend. Right? So instead of having to wait all the time, it could also invalidate commands. And you really wouldn't want to be the person who had an invalidation of commands, because then you would click and think that you could do something, and then you wouldn't be allowed to do it. You would lose your input effectively. But it's not something you can really do pure peer-to-peer.
Yeah, we speculated about doing that, and we were that game came out on Steam, and so we were using Steam sockets, which actually do peer-to-peer if they can, or Valve provides a relay server transparently if you need it. Yeah, that's good. So we always thought about doing our own relay server, and like you say, having some additional validation in there. We sort of thought of it as like the referee server as opposed to the game server. Because it's really not running the simulation. It's really just at the simplest level, just looking at the commands timestamp coming in and going like, you're too late. You don't get to run that command. Right. And then beyond that, I can actually also share that I know another game based on network dumps that I've done and looked at and investigated, that I'm fairly confident that Clash of Clans has that same deterministic thing running. But the deterministic server that's normally just a referee server, it's running a headless version of the game. And that headless version of the game is the thing that drives meta. So it drives like, you got points, you got XP, you won this. So that way you don't have to trust the client's kind of like, I won. Right. So there's a whole amount of gradation in this network model for like, for sure. Are you peer-to-peer or fully client server or somewhere in between? Right. It's very interesting. And the deterministic model comes into play too. And you were mentioning rollback. So Overwatch uses deterministic simulation advance with rollback in the event of discrepancy on the inputs. And the determinism allows them to basically they use determinism as their predictor. So you're not just extrapolating, you're actually running the same logic the server would run. So your prediction is perfect as long as the inputs are you've guessed correctly.
What's particularly interesting is that the best of breed first-person shooters that aren't necessarily bit-level deterministic, like Call of Duty, Apex Legends, Titanfall, Counter-Strike, these games do a very similar rollback, but in a different non-deterministic way. It's almost like there's a continuum between the deterministic lockstep mode and the GGPO style rollback for fighting games and so on, and maybe Overwatch is somewhere in the middle, and then there is a really not deterministic set of games that still do the same rollback called client-side prediction. So it's so funny when I teach programmers about game networking, it's like, every answer, they ask a question like, well, what's the best way to do this? Or should I be deterministic or not? The honest answer is always, it kind of depends.
Mm-hmm.
It's just such a complicated blend, a continuum between different approaches. There's no hard line between two different things. They all kind of blur together.
Yeah, for sure.
Cool. So I've got a really interesting question for you, and I guess this is one to end the show on. I think bandwidth is no longer as limited as it used to be. What do you think the future of RTS games is in a world where bandwidth is plentiful?
Yeah, it's a good question. I think bandwidth has become way more plentiful, and latency in some ways has gotten worse in some cases. So I have, on Desert to Karak, I tried to do some like back of the envelope modeling of, how much data did we actually have to pass around if we tried to go full client server. And I still concluded that it seemed like too much for the bandwidth of the time. Are we getting there now? Probably. I mean, you look at, if I can stream Netflix in 4K, then surely there's enough data to stream there to manage the state of an RTS game. We
need to really start thinking as game devs, like 5 or 10 years from now, maybe let's say 10, everyone's going to have a gigabit. Everyone's going to have a gigabit per second, not gigabyte, gigabits per second. And if you work out how much you can actually send up and down in the gigabit, that's a lot, right? Even if you are sending packets 60 times a second. And some people might have 3, 4, 5, 10 gigabits. So we're about to enter a very interesting world.
I don't know how much you know about the details of Planetary Annihilation, but I believe
they did hear they did it.
They tried to do something like that, but I think they had some challenges where they were sharing state that wasn't just moment to moment state, but it was like curves of where things were going to be moving in the future, with the idea that then the client could just keep following along the curve and they'd get to the right place. I think they had a challenge where in the heat of battle, those curves were updating so quickly that having a curve that went 3 seconds into the future doesn't help you when your unit is like under fire and changing its mind every 250 milliseconds. So I'm not sure how successful that was.
I was wondering how they did that, because you're definitely right. Because if you have a ballistic trajectory or a movement along a path, which you can see a classic RTS is composed, it is tempting to think about, well, can I network the actual primitives of movement? Right. But the one thing I would say is that while you could theoretically do it, that would be it would be impossible to bound the amount of bandwidth that sends, and that it would go up with activity, which you might have the steady state be quite reasonable, and then the classic RTS and battle would make everything blow up. Yep. So
we've got another game in development that I believe it gets announced in June, but that is client server and heavily based on entity component systems approach to things.
Oh, cool. So Mike Acton stuff.
Yeah. Well, I mean, he's
been doing great work at Unity on that. I mean,
so that whole
fantastic
like data-driven idea. We're actually using ENTT, which is an open source framework for ECS. But we've got quite a robust model because all the game state is in entities and their components. Component replication becomes the problem to solve. And so we've got good mechanisms for designating, which components update on the client, which update on the server, which ones get replicated, how often they need to be replicated, how to replicate distant entities versus ones that are closer to the player, and good rules so that we can actually put a cap on bandwidth, and we know, okay, given that I've got this many megabytes per second available, which components are the ones that are priority, and I should circulate those. It becomes a little bit like I think it's Fortnite and Unreal, where there was
it's very much like the Unreal.
That notion of like, how much do you update when, and what are the rules whereby you decide, what data gets updated.
I like to look at it like this, sort of like a priority accumulator, and you're kind of like, I want to hit this kilobits per second. And then you kind of have objects or components, and you're kind of like, you keep bubbling priority up for them. And then you pick the top end that fit into whatever packet you can send out, and then flip you take their priority accumulator and you drop it. So more important objects or closer objects accumulate priority faster and get sent often in every packet.
It becomes almost like a video compression problem, where you're trying to preserve quality of a data stream and hit a bandwidth target.
So what's really nice about this is that you can hit that specific target. There's a different way to do it. So this is how I've always done it in the past, especially when I was doing peer-to-peer in my first client server games. then I went to Titanfall with Quake and Counter-Strike Heritage, and they're also like the same guys who worked on Call of Duty. They do it a totally different way. What they do is they get a big vertical slice of the entire world. And I don't mean like every static building, I mean like stuff in the world, right? And they just really delta compress the shit out of that relative to the last one that you received. So they can no longer cap it at a steady state kilobits per second, but it's actually a very efficient encoding. And it's actually paradoxically simpler, right? Because you always have all objects at the same point in time. Whereas in the other one, you're trading temporal kind of like sloppiness, because it could be like, well, it gets an update. And the way that they did this is it's almost like it's gone full circle, Iggy, because what they're doing is almost like the RTS games. They have a snapshot rate of 10 or 20, and then they have a vertical position of all of the visual quantities for an object. And then they're rendering an interpolation.
Yeah.
That's how Call of Duty worked. That's how Titanfall and Apex Legends works. Isn't that
also means you've got full state on every client, right? So you're susceptible to memory hacks and things like that.
No, well, okay. So two things. The first one is it's a shallow synchronization for most objects rather than a deep one. So with the method where you have sort of like the washing machine in the Unreal way, you often have to send internal quantities like velocity or whatever, because you're going to be running between updates. You have to keep updating that object. But with a snapshot, you're really only sending often position and orientation or some sort of visual quantity for the object, unless it's a predicted object like a player. So it really just becomes interpolating between visual positions at 10 hertz to render them at 60. And there's a simplicity to that, but it has, the other thing you mentioned, of course, is that you can do a PVS, you can do a relevancy system, which like you mentioned, it could be as complex as like, don't send objects down to the client if it can't see them from a server PVS. And I believe Counter-Strike does that for for the reasons you mentioned, right? Interestingly, I can tell you that Titanfall 1 and Apex, to my knowledge, all objects are sent down. And the reason is it's just such a big world,
right,
that you would just go up high in the sky and see everything anyway. So the delta compressor, so it's the thing that I wrote, is the thing that takes that and just basically, as long as the amount of changes from one frame to the next are relatively small, it all just magically works. Right. It's quite a thing. So
that's even more like a video compressor than
totally.
Example.
So isn't this amazing? So the more you look at these different ways of doing networking, you realize that often all of them are the same thing. There's a lot of similarity between how the RTS games did, 5, 8, 10 hertz ticks and did the rendering with the later Quake networking model before client-side prediction. There's a lot of similarity between the GGPO deterministic rollback used for like Street Fighter type games and client-side prediction in first-person shooters. And then you have this interesting flavor, I like to call it, between the Unreal way with the priority accumulator and the kind of Quake way of the interpolating between snapshots. And every game does all of these differently.
Super cool. We're exploring a lot of different options in that space. Like you mentioned, we've done RTS games. We're also working on quite a variety of other things. So there's a action strategy game that's client server. That's the one I mentioned. Crossfire Legion goes early access in 2 weeks' time. That's very similar to Desert to Karak in architecture. Hardspace Shipbreaker has been in early access for a while, goes full launch on PC in a couple of weeks. That doesn't do multiplayer because we got so far down a rabbit hole of like crazy physics and things that we couldn't figure out how to synchronize it. But we've got some like online challenges and leaderboards and things like that. We're doing our first turn-based game is a game we've got in development. It's like a lightweight deck builder roguelite. So again, that's pushing us into new architectures. So constantly new stuff to figure out, and then trying to figure out, okay, what did we just learn on that last game, and how can we like make different mistakes this time?
I like seeing the patterns across radically different architectures and different types of games and going, it's all kind of the same thing. Yeah. Well, Iggy, thank you so much for your time today. If someone watching wants to come work with you at Blackbird, where should we send them?
blackbirdinteractive.com, and check out the career section. We're always looking.
Awesome.
We've also, as an added incentive, we've just started a 4-day work week. So we're
brilliant.
Working through that, which has been pretty exciting.
Just quitting my job right now. I'll be right there. Okay.
Excellent.
Iggy, thank you so much for being on the show. Have a great weekend, and everyone watching at home, make sure to apply, and you could go work with Iggy at Blackbird and British Columbia. Thank you.
Thanks, Glenn.
See everybody. Bye-bye.
Here's the hard truth. The internet doesn't care about your game. After all the blood, sweat and tears you put into making your game, you launch, and some players get terrible network performance. What can you do about it? Build your own internet? This is why we created Network Next. Network Next is a radically new way of linking networks together. It's a new internet. One where networks compete on a neutral marketplace to carry your game's traffic. Network Next puts you, the game developer, in control of the network. We monitor every player's network performance, and you choose when to accelerate them. Not only will you see better network performance for your players, you'll also have the security of knowing that if one network is congested, we switch to another in seconds. Now you control the network.